Okay, everyone, this is lesson 6.3. We are rounding down on the end of the semester. Yay. I've made it's 3 pages of chapter 6. I went through it and I made notes of all the important stuff. I left it in my vehicle, but I'm going to upload that ASAP. And it has all the important formulas you're going to use, mostly 6.4, 6.5, and 6.6. There is some over 6.3 though as well. It has the properties of an exponential function and all that good stuff. I'm going to upload that, and you're going to want to print that and have it attached to you when you're taking this final exam and doing all the work. So keep it out while you're doing your work so you can practice using it. And let's go ahead and get started on this. My camera's crooked. We'll get it all fixed. Share screen, document camera. Okay, so on these, it's exponential functions. I'll probably make it to number 5, and I don't know if I'll do a video of it by itself or not. On these, they're asking, is the function exponential? Is it linear, or is it neither? So remember, linear is a straight line. So for it to be linear, the change has to be the same each time. And then for it to be exponential, there has to be a pattern happening. And if we can find that pattern, that's what we're going to put here. So on x, -1, 0, 1, 2, 3, we added 1 each time. And I think that's what all of our x's are going to do. And from 2 to 3, that was 1. 3 to 6 was 3. 6 to 9 was 3. 9 to 15 was 6. Make sure I did that right. 2 plus 1 is 3. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 6 is 15. This right here is throwing me off. Let's see, if I had 3 to the -1 power, it's not going to be 2. 3 to the 0 power would be 1. 3 to the first power would be 6. This one I'm going to say there is no function. And let me double check because I've already worked all these out. Yeah, there is none. Because there'd have to be a pattern happening, and that one it's not there. Okay, same thing. Determine whether the function is linear, exponential, or neither. So we added 1 each time here. And then we went from 1/8 to 1, 1 to 8, 8 to 64, and 64 to 5/12. So each time here, these are going to be our, it's 8 raised to the exponent over here. So this is 8x. And I don't know the best way to show you this. So our function is 8x, because if I had 8 to the -1, if we wrote that only using positive exponents, we'd get our 1/8. If we had 8 to the 0 power, anything raised to the 0 power is 1. 8 to the first power is 8. 8 squared is 64, and 8 cubed is 512. So our function here is going to be 8x. Okay, let's keep going. So we have 3 here. 6/5, 6/30, 1/50, 7/50. So I can tell something is going on here. I know that whatever it is here, it's going to equal 6. You always want to look at 0 to figure out what it is. So it can't be 6 to the 0 power because it is 6. So whatever is multiplied by the 0 power, or whatever is raised to the 0 power, is 1. So I'm going to say 6 times something to the 0 power. And then looking here, since I have 6 on the top of this, I'm going to say that I'm going to have 6 times 5 to the 0 power. Or not 0 power, because that would be 1. 5x. And I did this because I know right here, whatever it is to that 0 power is 1. So it's going to be 6 times this. And then I know that it's 5 here because 5 raised to that -1 power makes it 1/5. So my variable that's multiplying by this, it'd be 6/1 times 1/5. So that's why I know the 6/5 and the 0 gave it away. I hope that makes sense. So right here, we have 6 times 5 to the x. And then we could check it here. So we'd have 5 to the first power, so 5. And 6 times 5 is 30. 5 squared is 25. 25 times 6 would be 150. 5 cubed would be 125. 125 times 6, 750. Okay. Determine whether the function given by the table is linear, exponential, or neither. If the function is linear, find da 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 da. All right, so we have +1 here each time. Then 0, 4, 8, 12, 16. So 4, 4, 4, 4. That's the same rate of change each time. This one is linear. And our formula, and this is, you're going to put it in y equals mx plus b form. So our slope, since our change was 4 each time, is 4. And then our y-intercept, when x is 0, y is 4. So we have y equals 4x plus 4. And linear. Remember that. I have the copy of my other page where I did this the first time to make sure I remembered how to do it. And I copied them out and they have all the answers on there. So I'm going to upload these with it as well so that you have, you can compare them if you're super lost. Do I want to do 5 now? Or give it its own thing? We'll go ahead and complete number 5. Okay. So you have to remember your rules for like moving up and down your transformations. You need to remember your transformations. And then on the little paper, I have the graph of a normal, like, words are hard. I have the graph of the normal exponential graph, and a normal exponential graph does this little number. So our positive exponent, positive one, is going to be this one. So we have no here. So y equals 7x goes here because this is our basic one. So I'll highlight them instead of marking them out. So then the one that's backwards should be this one. And I don't want to throw it off here. It's not times x, it's the exponent because it's exponential graph. So we've used this one. Okay. Now then, if this is -7x, I have -7 negative x. And if there's a negative in front of it, we are flipping it across the axis. Oh, which axis? So we have this one, which is -7x. And then we have the one that's -7 negative x. So I guess I should be doing these two at the same time. This is what I'm looking at right now. I have 7 negative x. If this is 7x, then 7 negative x, we're going to flip it upside down, making sure I'm doing it right. So this one should be y equals 7 negative x. Oh, guys. I think I've got these two mixed up, and we're going to check it real quick. If I put 0 in for x, I have negative 7 times 0, which would be negative 1. So 0, negative 1 should be on this graph. And this one doesn't have it. This one does. So this one is our negative 7x. Now if I put 0 into the 7 times negative x, negative 0 is still 0, and 7 raised to 0 would be 1. So this is our 7 to the negative x. I hope y'all realize I'm human when I make these. Okay, now then, since we've had that error, when we have negative 7, negative x, it's the only other one that's going to be upside down, though. So we have, so the upside down ones are the ones that have the negative in the front. And there's only 2 of them because that's positive. Well, that one's not, but that's a different story. Because now then we have the numbers on the outside that I want to do first. So the ones on the outside are this one and this one. This has negative 1, so this one's going to go down. This one, that is a positive 1, even though this is negative, so that means it's going to go up 1. Then right here it's 1 subtract, so that's a positive 1. So that positive 1, it's opposite world because it's with the x, so that's left and right. And since it's positive, that means we're going to go left, and then this one would be right. And then let's see, negative 7 on the outside is, don't want to say flip or mirror, flip across x-axis. That one's normal. This one is flip across x and y axis. And this one is flip across y. Right? So this was this, and then we went to y. So from here to here, and then we had the one that was both of them. So here, here, here. Okay. Now the one that goes down one. So good down. So this is this one. So y equals 7x subtract 1. Our up 1. So this one went up 1. So y equals 1 subtract 7x. And it's flipped upside down because it's that negative 7x. So it's the negative function, but it went up 1. This may be the most confusing problem on this lesson, which is kind of good at the same time that it is the. So our left, so this one moved right. And the way to check these is that our normal functions right here should cross at 0, 1. And this is all on that exponential properties paper that's in the truck. So this one crosses right here. Really? And this one does too. That don't look right. Well, okay. So maybe it's not, well. I know that this has a negative x and this is the positive x, so the positive one has to be this one. But why did they not move it like it was supposed to? And since that has that negative x, I know it's going to be the backwards one like the negative x ones. So this is y equals 7, 1 subtract x. but it's on the inside and it don't move left and right. They both move the same way. And one's positive and one's negative, and that really throws me off. Change this on here for when I post it. So this had positive x, and this one had negative x. So that tells you which way it's supposed to flip. That was super confusing. Let's check with the other one. And they're in the same order, so honestly, you're going to be able to get this right. We have negative, negative, positive, positive. Subtract 1, negative to the power. And the graphs match. It's just that one had 8. Y'all can't see it, but now it's this way. 1 subtract, 8, 1 subtract, negative, negative. Okay, so there's the first set, and just look at your notes. If you get confused, email me though. I'm sure we can try and figure something out.